So when we're talking about the key features of quadratics, the one thing that I like to take care of first is the increasing and decreasing. It's important to note that when you're talking about where the function is increasing and decreasing is you're talking strictly about the x values. So what I typically like to do is start by putting a dot on the vertex and drawing in the axis of symmetry. And all we're going to do is just name what these x values are on this side. So what are these yellow highlighted x values right here? And those yellow highlighted x values are -infinity to -4. And this side, these purple values are -4 to infinity. Okay, it's always going to be -infinity to the x value of your vertex and then your x value of your vertex to infinity. Always, always, always. So always split that graph in half and look at it like that. Okay, and so then when we're talking about increasing and decreasing, I'm going to just go highlight this part of the graph. So on this side of the graph, okay, there, if I put a little guy on the graph, okay, where is he going? Is he going uphill or downhill? He's going uphill. So that means that this is increasing, that interval. Those x values, -infinity to -4, are increasing. And if that guy keeps going, then he is decreasing. We always read that graph left to right. So he's going up, 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 and then when he gets here, he's going down, 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 down. So this side is the decreasing from -4 to infinity. Okay. The vertex is obviously at -4, 6. Okay, that means that axis of symmetry is at x equals -4. The domain is always going to be all real numbers or -infinity to infinity, because you're asking yourself what x values exist, and every single x value exists with quadratic equations. It doesn't matter what kind of quadratic equation is, if it's opening up or down, it will always be -infinity to infinity. Okay. That vertex, we need to talk about, that is a max, because that's the highest that graph goes, and it has a max at 6. Okay, and when we're talking about the range, we need to know how low does this graph go. So you always have to go low to high. How low does this graph go? And this graph never stops going down, so that's -infinity. And as we go up, we don't go above this value, which is 6, and we use a bracket. This is the only time you're going to use a bracket is on your range, because that goes all the way to 6. And then our x-intercepts are -11, 0 and 3, 0. My y-intercept is where I cross the y-axis, which is right there at 0, 4. Okay. I'm going to go ahead and do number 4 as well. Okay, so let's start by doing that increasing, decreasing again. So I'm going to go ahead and draw in that axis of symmetry. And every single time, no matter what, I'm going to go ahead and label this left side. So this left side is -infinity to 4. And the right side is 4 to infinity. Okay, and then I'm going to ask myself, what is this side of the graph doing? What is it doing? So if I go put a little guy on the left side of the graph, he is going down. So this interval, -infinity to +4, is decreasing. Down, 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 down. Then when I get here at 4, I start going up. That vertex is at 4, 2. That axis of symmetry is at x equals 4. That domain is always all real numbers, or -infinity to infinity. That is a minimum, that vertex, and it has a minimum value at 2. The range, how low does this graph go? So what is the lowest it goes? What is the lowest y value? And I don't go below here, so I go from 2, and I keep going up, so I go from 2 to infinity. I never cross this x-axis, so I don't have any x-intercepts. None. And I only always have one y-intercept, and it looks like it's at 0, 10. Look at Delta Math. You have 14 problems. The parabola features for Monday. So all this asks is, you just got to make sure you read, determine the coordinates of the vertex. So I know that that's 1 point, and that vertex is -1, 2, -1. Okay, and hit submit. Okay. And then the next problem says x-intercept. So then I would have 2 points and go ahead and put those in. Okay, so those shouldn't take very long. This part says determine the domain on which the following function is decreasing. So it doesn't mean find the domain, it means determine the x values on which the following function is decreasing. So notice we're decreasing on this half right here. So remember, we're using the x values, so we are decreasing from 4 to 9. Notice there's no arrows on there, so we have to stop at 9. So we have from 4 to 9 is where I am decreasing, because it stops there. Remember, we're only talking about x values. Okay, so see us going down, 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 and we stop right there. Okay, let's do another one. This says increasing. Now, the arrows are going down forever and ever, okay? So where am I increasing? I'm increasing on this side of -1. So I'm increasing from -infinity to infinity. Not to infinity, sorry. From -infinity to -1. And then it should show you. It's thinking really hard. There we go, that yes, I am increasing on this side from -infinity to -1. Please make sure you use those x values, not your y values. Try one more just for good measure. Same thing where I'm increasing, it's going to be -infinity to 4 because I'm going up here, but remember we're stopping at that x value of 4. If you could draw a line down there, it would be from -infinity to 4. That's it.